Hello, everyone. Oh, don't fall off, kitty. Come on. Don't step there. Sorry, the cat's getting on my lap. And he has tipped my water over before, and I have a full glass. So, making sure he doesn't knock everything over. Okay, so, I guess I don't need my headphones, do I? Forgot that. It's a habit. If you haven't watched my stream before, welcome. Check the time codes in the document or in the description below. It tends to be a pretty long stream, so you may want to check that out. He stepped on the have an I/O board, and he stepped on the pin headers bit and almost fell over. We've all been there. Stepping on pin headers is no fun. So I'll just take a little while to get going. Hey, PT. Well, since we just got started, I was kind of right on time. So hello, Unexpected Maker. Hello, Bruce. Hello, Beata. Hi, Randall. PT. Hello, Andrew. Hello, Bruce again. And Mark. Thanks for stopping by. I'll take a couple minutes before we get going. Hello, Anthony. Oh, I should also say that if folks do find that YouTube will be on a bit of a delay because I have the auto captions on, so it's normal latency on YouTube. If you want, I think Twitch is going, so you could hop on Twitch and it'll have less of that. Bruce says, "Did you change your lighting?" I think it's just the time change, right? It is still light out. I do have the shade down somewhat. Don't bite these. He's like, when he is all purring and stuff, he just wants to rub his face on everything. And I've seen him like bite it. I don't know. Can I cat cam over here? Come with me. Come with me, cat cam. Can you see him? I can hold it there. Say hi, Spook. He's gonna ruin my keyboard. I can't. There, that's, I guess, a good lap cat cam. Let me say hi to some more folks, and then we'll do housekeeping. Hello, Kinger North. Hello, X Micron. Hello, Cedar Grove. Hi, Paul. Argon 1M2. Nice. Hello, MD Roberts. Hello, Chi. Hello, Foamy Guy. He's a happy kitty. It is nice that he's been doing better. He's actually able to get up on the desk all by himself. Scale this down. Oh, and I didn't pause the videos coming back to me yet. Simon says, "Hi, Spook. I hope you're doing well." He's doing really good. It's been really awesome. He's been doing much better, so thank you. Okay. Let's do housekeeping. And I'll take a time code. If folks want to take, so David, I think, is out today. If you want to drop like titles that I could put in the YouTube chat, or like that I could put in the time codes, put them in the YouTube chat. I'm actually going to try to pull the chat logs back out and maybe use those in the description, because I think they are time coded for me as well. But I'll take a time code here too. And set it up. Hello everyone, my name is Scott. Let me put cat cam back now that the cat's off my lap. This is obviously a pretty relaxed stream here we've got going on. If you don't know, my name is Scott and I work for Adafruit on CircuitPython. Adafruit is an open source hardware company, open source hardware and software company based out of New York City. And I work for them remotely, so I'm actually in Seattle here, which is why my times are usually in Pacific first, because that's the time zone I'm in. CircuitPython is a version of Python for generally microcontrollers, which are little inexpensive computers, have like tens of megahertz, I should say, of CPU power and up to maybe like a few K or up to a megabyte of RAM and flash. However, I've been working on getting that on the Raspberry Pi, so CircuitPython is actually going to come to a world where we have a gig or more of RAM and flash, and hundreds or even over a gigahertz of CPU power. So it's going to be pretty wild. We'll talk about that in just a bit. If you want to chat with me and others, we have a Discord chat that lasts kind of all week. You can go to adafru.it/discord to join there. That's a way to just keep attentive of what's going on besides these deep dives. These deep dives happen every week. Normally Fridays at 2 p.m. Pacific. Occasionally I shift it to Thursday if I do want to do it on that day, or do it on that week, but not on that Friday. But I haven't done that in a while. Chi says everyone here is very nice on Discord. Yes, we do have a code of conduct, so if there are mean people, we try to get them nicer, and if that's not the case, we'll boot them out. Normally Fridays 2 p.m. Pacific, we go for about 2 hours, so we got lots of time for questions. Go ahead and ask questions if you have them. I'm happy to take detours and tangents and answer things the best that I can. I should say, in terms of timing, next week will be on Friday as well, but the week after is Thanksgiving here in the US, so I'm just going to skip that week. So be aware of that. And that's it. So last week I was having USB troubles, and I did a couple things that I talked about on the stream to fix it. One thing I did was I got this like fancy USB card, and I tried to plug in like the Salier, and that just like didn't work. So I was very, very frustrated. I actually returned it. So don't take that as my endorsement for that USB card. And I actually picked up a less expensive version that doesn't do quite as high speed, but has the same approach. And it turns out that I was using the card just before the stream, and has the same problem. So let me just highlight this right now, and maybe somebody who works on the Linux kernel can fix this bug for me, because I think it is actually, it may be a software bug, not a hardware bug. But these are the errors that I'm seeing. It says error transfer event TRB DMA pointer not part of the current TD. And it's really frustrating that this isn't working. And I think this card that I have is like half the price, and it still seems to work okay. Generally, this is the first trouble I had with it. I was running a Salier on it yesterday, and it worked okay. So I might just hang on to this one, but yeah, Chi says, lol, that error seems to assume a lot of prior knowledge. Yes, it does. Yeah, so this is the first I've seen it. The other thing that I did to fix my issues was I actually got a new motherboard. I think I mentioned that. And so this weekend I swapped in the new motherboard, and that's what I'm using now. And I RMA'd the other one, so hopefully they'll fix the other one as well. So that's been my adventures in poor USB support. It actually does make me consider like maybe trying to do development on Windows. That might be hearsay, but if they have a USB stack that is more resilient than Linux, like, they've been doing a lot of good work, and I think maybe I should try it. Yeah, I know that's kind of blasphemy, but so there was a USB port problem with the old motherboard. I think so. So this is what I wish motherboards were clear about, right? Like it's the topology is PCI connects to USB, and then so there's a bottleneck there in terms of like how much data you can go from USB to there, and then everything downstream of that is basically shared, right? So a, a root hub usually has like one to four ports, and then you'll have intermediate hubs that split that out to give you more ports. So I wish the motherboards were super clear about like these USB plugs go back to this hub that go back to this root hub. Bruce says, I've had less issues on my Windows laptop and USB versus attempting the same with an Arch laptop. Not a definitive endorsement. Yeah, like the hubs themselves, like what chipsets they are, matter some too. So on Linux, what you can do is you can do LS USB, USB-T. And one thing that I don't understand is why this view does not have the names of the actual devices. Like, I'm really trying hard not to end up as a Linux USB developer. Like, I kind of want to just do it and fix it all, or like start working on it, but at the same time, like, I'm sure it's a very difficult problem, which is just really frustrating. So this LS USB-T can give you an idea of like, here's the root hubs, and then everything from there is a shared resource sort of thing. So I think what happened on my other motherboard is like somehow one of the hubs that was on the motherboard failed. So like a bunch of the ports no longer worked, and if I booted it up, I could see that there was like descriptor enumeration errors. So it's all very familiar given all the USB work I've done. Yeah, Bruce says, my only issue is WSL2 and sharing ports. There's a workaround, but I do wish I could just assign a port to the lightweight. Yeah. Oh, let me try that, Mark. I mean, I don't really want to, like, I think I would try to do it outside of WSL, but again, I haven't tried it. Oh, there you go. That's kind of weird. The IDs are nested to the interface. That is better though. Thank you, Mark. Like, these should be higher level, not lower level. Yeah. It's been so frustrating. It's USB stuff. It's working though. We've got 3 camera feeds coming in, or 3 video feeds, so it's not. I'm asking a lot of it, to be fair. Like, I'm sure I'm on the. Not a fan of building CircuitPython on Windows. Maybe it works. Yeah, see, I haven't tried it, so this is just my ignorance being like, maybe that world's better. I could be very wrong. I do like a lot of things. It gives more information, but that doesn't mean that it's easier to do. Motherboard issues are a common thing. Mine aren't making my computer do weird things at times. Yeah, this is not a cheap motherboard. It's like the Asus Crosshair Hero 8. Like, it's like the top of their line that's not like twice as much as the previous one. One thing I didn't know about was LS Topo, which is pretty neat. I don't remember what I was following, but it gives you like a diagram of your CPU, basically. CPU and memory. So I've got like the 16 core is that right? Yeah, it's not showing me everything, but it's showing me like the cache, all the caches in the CPU and stuff, which is really neat. So you can see like core 0 to core 15. So it's 16 core, 32 thread. And then here's like the PCIe tree for like my hard drive. my network, other stuff as well. So that's been pretty neat too. And there is an equivalent for PCI as well, so you could do like LSPCI. But I really I would love to see like a comprehensive like view of the world, and then tie that back to like the actual motherboard and like how does the motherboard break out all sorts of like PCI and USB lanes and stuff. So yeah, that's been a saga. The other saga that I'm going through, nice. It's a new tool for Mark. We can trade tools. The other saga that I've got going on is I'm like super close, so let me take a time code actually, since David's out. So let's talk about the Raspberry Pi. As you know, I've been working on getting CircuitPython running on the Raspberry Pi, and that's not the Pico. For those of you who are new to the stream, that's actually on the Raspberry Pi Broadcom chips. And I've gotten Flash working, her SD card's working almost. The problem is the almost bit. From time to time, I'm getting to the point where I can't, like something crashes or it gets in an infinite loop and it stops working, which is extremely frustrating. So if I just power on, so I've got a 0 to W here. I don't think I showed this last time. I don't know. I don't remember exactly how far I was, but so here's a 0 to W is here, and it's underneath my like debug hat thing. So it's got the USB to serial output and also an SWD connector. And let me try to lock that focus. So I've got power here. So let me just plug it into power. And before we do USB, I'll just show you that I do have a number of things working. So that's up and going. And desktop with overhead. So if we look here, here's the Raspberry Pi's output. So you can see it's enumerating the card, and I'm actually reading the partitions. So there's like the MBR, which is the master boot record in the front, that tells the OS how things are split across the card. And so what we can see here is we have one partition that starts, so it turns out 2048 is the number of sectors in a megabyte. So this is at 1 megabyte and it goes for 255 more. So it's the first 256 megabytes are the boot drive. And then the second partition here is what will be CircuitPython. And so you can see that we're successfully reading the card. We're doing the frame buffer stuff, which I forgot to plug in, so you won't be able to see that. So now so this is not over USB, this is over USB to serial. But I can do import os.lister. And now I get the files that it's created on there. I can open code.py for reading. And I think it's just empty actually. Because it's doing I haven't allowed CircuitPython to write the drive, so I can't write it from here. But it does run if it was non-empty. So that's cool. I don't think I showed, oh, last time I don't think we had UART sending communication to it working. So I did get interrupts working, mostly. There's actually a bug that maybe I'll get sucked into here. But as you can see, I can type in. So I do have the UART interrupts working successfully, which is what I think last week I left off with, is like we got UART out, but we did not get UART in. So UART in is working. And then once I got that working, I also got USB. Once interrupts were running, USB was running too, which is pretty neat. So then I was working on the SD card stuff, and that has just been also very frustrating. If you saw me on Show and Tell on Wednesday, I was like a little disheveled because I had like woken up and like been working and working and working and working trying to get it a demo going for Show and Tell, and I like made a little progress but not quite enough progress. So let's just see what works. Hopefully it won't take the stream down, because the USB is definitely not super happy with me, but I'm going to plug into the second USB port another one. And let's just flick it on and see what happens. I was looking a little rough. I took a shower after that. I took a break. It was good. I'm just like so close. Heyo. So here I'm a little closer. So CircuitPy showed up when I turned it on. Let's see if I can load it. I can't. Like, it's trying. But if we go back here, now it's hung. So let me turn it off. So hopefully everything is working. It appears everything's working still. And let's just take another gander at this backtrace before we move on to other stuff. ls topo ASCII. Oops, that's not what I want. Okay, so let's GDB in. See where we're at. Okay, so this is what it was doing when I looked earlier. I might have to take a look at this. This is a new bug for me. I'm like in the IRQ. But if I do a backtrace, like it's broken. And let's see. Info registers. Yeah, so I'm not sure where I'm at. Interesting. It's not telling me that we're in something particular. And then what I just realized also is that I could look at the interrupt controller state. Pending 1. I wonder if it's an interrupt that we're not servicing correctly. A lot of nested PCI bridges. I think that stuff is really cool, and I think it's important for people to think broadly, not just about their CPU, but the memory structures around it. I think the RP2040 did a good job, and Apple does a good job with their M1s. I think that's one thing that sets them apart. Okay, here, so it looks like timer 1 is pending. I wonder if this is a timer issue. Like, I wonder if maybe, I don't know. One thing that could cause this is if there's a write happening to the file system and then timer 1 is turning on to turn on the tick. Let's just see if I can't fix this. That would be epic if I could fix it. I do have other stuff to show, so don't let me spend all the whole time on this. We've made a lot of progress on the BLE apps that I want to take a look at. But this is why I haven't gotten to it yet, is because I've just been sucked. Like, I'm so close to having CircuitPython working like you would expect on these things that it's just like incredibly frustrating for me. So I wonder why. I wonder if we're stuck in an interrupt loop. So an interrupt loop happens if an interrupt occurs, but you don't clear it. And how would we know if that were the case? Supervisor shared. No, this is the wrong supervisor directory. I want the Broadcom one. Supervisor shared. Port, use port is what I want. So what we can see here, get raw ticks, we're using the system timer, and then here's the timer interrupt, where we reset it, and then we clear the bit. I wonder if we just didn't do that, whether that would be a problem. It won't auto-reload then, but I wonder if it would work. So the other thing that I've done is I actually have it building images now. So you'll see that it actually created a disk image here, which allows me, I'll just show this first. So I'm going to unplug. I really need to get power switches for these micro Bs. So I'm going to plug in the SD card, but instead of doing my manual thing, I'm actually going to show you with RPI Imager. So I can run the Raspberry Pi Imager here, hit choose OS, use custom, and then it's already up in this directory for the 02 build. So I'm just going to select the zip file, select the SD card, and I'm just going to let it write. So this is what I'm experimenting with, is that it does, the imager may erase the whole thing, which is kind of unfortunate, but if you look at the output here, it actually says that it zeroed out the first and last megabyte of the drive. So what I have is the CircuitPy drive lives within those bounds, so that hopefully when you do an imager, it will actually preserve it. You should always back it up if you really care, but I think, at least for me, the way that this is, like, it should preserve CircuitPy. I don't actually need to use the imager every time. I could just copy it to the drive itself, but I thought I'd show that I do have disk image artifacts coming, being spit out now, which is what we would need to end up in the Pi Imager. So I was figuring that out yesterday. I'm pretty happy with how it turned out. I can just show briefly how it's done. Let's just take that out momentarily. And let me just show. In the makefile here, we have this new disk image step, and it depends on the kernel image. And what we do is first we create kind of an empty file of 256 megabytes. We format it with an MBR. We format it, we add a partition for the remainder. I guess this should be 1 megabyte. And then we do a fat file system at that offset. And then what we do is, it turns out there's this package called mtools, which is like took me a while to find, because I was thinking I would have to like create a loop device and mount it and blah blah blah. But it turns out a lot of these tools you can use directly with the file. You just have to know the right way to do it. So mcopy, what it does is it takes -i, meaning for image. So it says like, here's this file, and at the 1 megabyte offset, there's a fat file system. So copy these files into it. And this first line ends just like the second one. So it's like the colon means the disk you're doing on the line. And the second one is like, if it was C colon something, C colon, like in this case, it's colon colon. So this copies these files from my file system into that image. Then I zip it up, and then I remove the irregular image. So I was really happy that I got that building. So this will allow you, when you install CircuitPython for the Raspberry Pi, to do it by just using the imager to image an SD card. And it snags, you can see here that it's snagging like the boot code and the start elf and all the stuff that's usually in your boot drive, and putting it all on there for you. Which I'm pretty happy about, which is why I'm like so close. There's a couple other things I want to do, but like this drive stuff is just so close that it's frustrating me a lot. So let's see how it does here. If we don't do the tick stuff, maybe that's our problem. So let's power it on. I don't know why it goes straight to the REPL. There must be like some random character here that's happening. So now I'm going to plug in the other cable, which I need to actually... Imagine if you can use an UF2 to flash a Pi. I thought about it. What we could do is like provide an image that does UF2. All right, CircuitPy showed up. Can we open it? No, we can't. Oh, we can. It's just slow. For some reason, the flash stuff is really slow, which is unfortunate. But let's push our luck. What do you wish to do with this file? I wish to open it. Okay, so where's my output? So let's try all the things here. So let's close PyImager and do TO dev serial. So what we have here is on the left, we're connected to the serial via USB directly. And then on the top right is the mirrored version of that via the USB to serial. So now what we have in this corner here is the code.py. So let's just try that. If we hit print hello world and hit save. Okay, so that didn't do anything, but we stopped the timer from working, and the timer is the thing that counts down to do the auto reload. So let's just hit Control D, and we can see it said hello world. So that's super exciting. So it successfully wrote live from the internet. I don't know. Let's try it again. And again, it didn't reload because the timer is not on. But if we hit D again, it's almost working. We've narrowed down the reason that it's not working. So I'm going to keep in this vein, even though I have some other exciting stuff to show as well. Pierre said, so it's going to be an image and not a UF2 makes sense. I think an image makes sense. We could potentially actually do tiny UF2. That's one thing to think about, is we could basically have another bootloader where tiny UF2 would just act like normal. But I think for the Pi ecosystem, it makes sense to have images as well. Mark says, do you think the Pi Foundation are designing an ARM-A processor with a UF2 bootloader built in? Surely that's the future. I mean, it would be cool. It would be cool. They have their bootloader, right? Like, they have a bootloader, the bootcode.bin or whatever. So they could actually do UF2. Actually, I wonder if we could run bootcode.bin. Yeah. I think that would be neat. It's not necessarily as clear about what a UF2 bootloader or Raspberry Pi means, though, given that the files that it boots are on SD cards, and like the bootloader knows how to read in a file system on the SD. It's not like on the micros where you're like running directly from things. It's not as clear. So yeah. It's not as clear what UF2 means in that world. We could fake it, but it's not. Like, you could have UF2 write kernel 8 image only and stuff, but that's not necessarily what you actually want. But yeah. Okay, so let's see what I messed up. I want to do ocular. So something is different between the BCM 2711 and the 2837, which is the, so here's the notes about that. Actually, do we have, are we J-linked in? We're not J-linked in. Okay, so I'm gonna disable USB since I'm gonna J-link it. I wanna just see if the SVD file looks correct for the timer, because it's possible that our address for the timer is wrong, and that would mess everything up. So my theory is that we're successfully enabling it, but we're not successfully saying that it's been handled. SVD, sys timer. So that looks correct. We can see that the M1 bit is set, and that's the bit that we're not correctly clearing. And if we look at C1, max arg is this empty sequence. I don't know why that's not happy. So the channels 0 and 2 are used by the GPU, and then C1 is the one that we're trying to set. So the other thing that could be happening is that if my IRQ handling code's not correct, that could be a problem too. So let's take a look at the peripherals code and make sure that the interrupt handlers are right. And they're probably not. Oh, no, maybe they are. That's right, I have them in the same. So this is the timer 1 IRQ handler. So that looks correct. So let's enable these. And let's just do a print here. Let's make sure we are ticking. So I'm going to make again, but I'm not going to use Raspberry Pi Imager. I don't have the network boot going, which actually has been working pretty well this week, but because I'm on the 02W and didn't want to mess with it, I haven't net booted. So I'm going to do it the old school, move the SD card away. Everyone's distracted by LS Topo. Do you mind dev questions that are related to Adafruit libraries, though not this specific effort for Raspberry Pi CircuitPython? I don't mind at all. I'm happy to go down other routes. I've had really good discussions about things that are unrelated to what I'm working on, so that's totally cool. And if it's too big of a topic, I'll let you know. Ports, Broadcom. I gotta change my setup for this. I think I've talked about it, but I have like a proximity sensor next to my trackball that tells when my hand is there. And it's just like every time I'm like ending up moving my trackball and it gets me out of range, and I type ends everywhere. Okay, so I'm just gonna copy the kernel image back over. So this is the old way I was doing it. It's a lot faster than the Imager because the Imager is copying everything. And I really need, really need to get some USB switches so I'm having to plug and unplug, which is just not a fun thing to do. So before we connect USB, well, we can see that the tick is working just fine. Or is it? It's still going, so I guess let's just see what USB does. The switch on this USB cord is like really disappointing. So the ticks are still going. Guess it's gonna be even slower. Huh. I wonder. Like this could be that like the infinite loop sort of deal. It's kind of hard to tell if there's anything happening in between because obviously it's just spewing ticks. So enable, disable. I don't think I actually showed, I don't think I've showed you this code. USB is not too unhappy, which was nice. It is weird to me. I don't feel like it should be. It's just in the wrong spot. I need to switch it to a touch sensor. Does USB device boot work on the 02? I don't know. I haven't tried the USB boot mode. Oh, so N. Lindholm has a question that says, I tried to submit a PR to Platform Detect, but it failed testing related to pylint and the no self-use check. I see there are some items in the file using disable no self-use and others using enable no self-use. Is there a rhyme or reason when to enable or disable the no self-use check, aka where in the file to put the function object? So I think a better way to fix that is what you can do is you can mark a function as static. You can do @static method, and then actually remove the self from it. Like, you shouldn't actually need self in the arguments if you're not using it. You want a static method instead. But obviously, I'm not sure Melissa knows that. That's why I've seen it other ways in that code. So you could ask Melissa whose code that is, but you could also just make them static methods, and then pylint won't complain. Dexter asks, have you used the LEDs on your dev board much? Just briefly. I was using it. I was using one of them just as a trigger. So when I was doing a Salier, I was having one line go high when I wanted to start the recording. And I was using one of the LED lines for that. So it's kind of nice to be able to visually see it too, but they're most useful right at the start when you really have no, like if you don't have prints or anything working, LEDs are really nice. But at this point, because like I've made a lot of progress, they become less and less useful. Okay. So this is the interrupt handling code, and yeah, I should just cover the BLE stuff, but I've been so deep into this stuff already. So here's how so this is like, if it's not the Pi 4, then this is what happens. So while anything is pending, so the basic pending register is interesting, and I think I kind of showed it. Oh, it's still ticking. The basic pending register is not here. It's here. So it's here. So one thing that's interesting about the basic pending register, it's kind of this hodgepodge of interrupts lines. There's like these individual ones. And I thought USB was there too. Oh yeah, USB is here. It's a weird order that it's rendering it. And then there's also these pending ones. So these are ARM ones. These are these two pending ones. So these pending bits are aggregates of other stuff. And then these are individual ones. So if pending 1 or pending 2 is set, then you have to look at the second register, which is what I just did. So here's pending 1, and you can see that timer 1 is on. I don't know why ticks are enabled perpetually. That makes me think that they're not working correctly or something. So while any of them are pending, we get the current pending. We get now we try to find the interrupt ID. So we say interrupt count is the interrupt count, which is higher than any of the values. And then we look at the locals first, which is the first 8. And if any of those are set, then we do that and we break. If we haven't found anything, now we look in the last directed ones, and the number translation to the bit is here. And then finally we do the 2 pending registers. And there could be a problem here, but it seems to be okay. It could explain why it's so slow if the tick is always on. So let's keep going down. So this is all the ways to find the interrupt number that's active. If nothing's found, we break out of that loop that handles all of them. Otherwise, we call the interrupt handler, which is where this tick call is in. So clearly that's working. And there's this current interrupt thing that allows us to say whether we're in an interrupt or not. And then there's this enable interrupt stuff. And this is where I suspect there could be a problem. So if it's not the Pi 4 and the number is less than 32, we use enable 1 or 2 or basic for the last 8. Get enable is the same. And then disable IRQ looks correct. Which makes me wonder why ticks are always on. Like, I thought they should be on demand, and if they're not, that would explain why. That would explain why it's not. I just had this thought in my brain of like, did I get the MMU actually set up correctly as well? Or are we running without caches? I think we're running with the same caches. So this looks correct for disable, but it's also possible that it's not correct. Like the addresses could be wrong, maybe. So if we go back here. See, this is, oh wait, no, the enable disable is, what's weird is that that number is higher. All right, let's get rid of these ticks. The ticks are bothering me. We remove them here, but let's do enable tick. Whoa. Do you have to flash anything to the Pi to get this to work, or can I make the image and try it on a 3B+? You could definitely try it on a 3B+. I think the challenge with the 3B+ is I'm not sure that it has anywhere to do the USB. So that's the problem, is that you have to have native USB broken out directly from the board. So that's why the zeros are great, is because they have the micro B connector. Otherwise, you'll have to do it kind of through the UART interface. So I'll probably, like, you'll be able to make a build for it. And in fact, you could probably just reuse the same build and it would be just fine. But I don't think I want to actually release builds for devices that don't have the USB plugs. On the Pi 4, you can actually, like the Power C. Yeah, the Pi 0 will be better for the USB behavior, but the original 0 I haven't added support for yet. It shouldn't be too hard, but it's just like, I gotta focus. It's a different CPU, it's not different peripherals, so it's a different problem. Okay, so let's stop this madness. Stop this ticking madness. really need a switch. Switches are so much nicer. All right, we're no longer ticking. It shouldn't be running all the time, though. Try the 0.2 then, back in a bit. Yeah, 0.2 is super close. That's what I'm running on right now. I actually picked up a second one during show and tell. Kevin from DigiKey was like, "We have them in stock right now," and actually, we could take a look if it showed as 2, and then it kept showing as 2, which was weird. Nothing. Oops. Oh, that's within results. Oh, yeah. So you might actually be able to buy one. Looks like they're still in stock. It says they're still in stock here. Yeah, DigiKey has 2 in stock all the time. Interesting, that's how they're limiting people buying them. Does that mean I could have bought 2? I should have just bought 2 then. Oh, I'm kicking myself. I bought a second one because I always want to have a backup for something here. I actually bought a second Pi 400 as well. Oh, Bruce says I bought 4. Oh. Well, if anybody wants to pick them up, I recommend it. Kicking myself for... I'm not going to order another one, but yeah, two's a great way. Good to have backups if you're doing anything with it. It loads code that acts as an SD card reader by default, but could be pointed to CircuitPython instead. Huh. So yeah, it looks like they're still in stock on DigiKey. I don't know how many they got, but they're listed weird, but the description is 02W. So maybe it's kind of sneaky. Yeah. The Flirt cases, I saw them on Amazon for like 13 bucks. I was thinking about that. Did I copy it over? I think I did. I think Lamore has some Pi 02s stashed if I ever needed them. And I could probably ask the Pi folks. If I ever like broke 2 of them and really needed another one, I'm sure I could beg. Okay, let's see what this does. So here's an enable ticks. Oh, the enable ticks could be on because of the display. That's what it could be. Wow, is it just like super slow? Is that the problem? It's just slowing everything down because we're ticking all the time? This is a case where it could be beneficial to like set a pin high and low to see how long ticks take. I wonder if I should do that. Let's turn the display off and see how well everything works. Let's try that. That will isolate my issues. boards 02 board. Don't need this SD card stuff anymore. And do that. It's interesting because I don't actually have a display connected. Octoprint. Okay. See how well this all works now. I think the supervisor tick is for the display update scheduling. Yeah, so it's still running the code.py. It did seem to be quicker, and we see that it's not starting ticks, so. Plugging in the second one. Trying to scooch it over. Got a CircuitPy drive. It's just really slow, which I'm not sure why it's, I don't know why it's asking me what I want to do with the file. Like, you know I want to open it. Wow. So there's the auto reload enable. So if we're not in the REPL. So it's working pretty well. Anybody want to try it? Want to sacrifice a 02? Well, it'll probably work. Sacrifice an SD card. Who wants to try it? Cool. I think that's working well enough for me. I wonder if, yeah, Bruce has 4 of them. I wonder why the timer thing is having so much trouble. Git submodule is killing you. I'll send you a build if you would like me to. I'll send you this build that I just ran. I'll post it on the Discord here. Disk image. I love that it's 12 megabytes. That's mostly all of the other files. So that's for the 02W. Turn and burn. Did I hear try something? Yeah, trying the 02W build for CircuitPython. Haven't tried to build CircuitPython yet, but MPy built quick enough on a 4-core 2 gig VM on my desktop. That's good. All mine are too big. What do you mean by too big? Like physically too big? One thing I have is I have these I don't know where these go. I think we carry them in the store. But I've got these SD card holder things. They're really handy, and then I just have them in a small Adafruit box, which is nice. Yeah, you can use that old 4 gig card. CircuitPython's not going to know what to do with itself with 4 whole gigs. It should set up so CircuitPy is that giant. And maybe that's why it's slow. Uh-oh. It says 2 terabytes free. I think this card, I was experimenting with this card earlier. I might have messed it up. 32 gigs shouldn't be too big. Try it. So any card that's more than 256 megabytes should work, because that's how big the image is. So the way that it works is that the image that I dropped in there has a single partition just for boot. And then I have CircuitPython code that looks at the partition table. And if there's only one partition and it's only that 256 megabytes of the start of the card, it actually goes and writes the second partition in the MBR for the rest of the card. So like in Raspberry Pi, you have this problem where you download the image and you have to put it in a card that's at least as large as the image, but then like you have to run something, I think, to resize it to get the rest of the thing. So this CircuitPython image is the first 256 megabytes. CircuitPython checks the MBR and modifies it to add that second one, add the second partition if there's room. So I kind of want to just erase this entire card because I was testing it earlier and I had a bug. I had a bug that so fat might have messed up, and that might be causing some of my problems here. 128 megabyte cards are too small, although we could rearrange it so that it would work. But generally they're too small. So let's just RPI Imager this, because I think it has a way to just erase it all. Like at the bottom here, it just says erase. Did you settle on pin names? Is it the same as with Blinka on any Pi, or maybe we don't have GPIO yet, do we? So digital in-out should work. I haven't added all the pin names yet, though. And that's a good point that I should take a look at what Blinka calls everything. But I haven't, that's one thing I have to do is actually get like board dot working. Okay, so what do we have now? We just have one removable drive and it's 8 gigs big. That's right. So cancel, safely remove. And now let's select our custom image. This might not be good enough still. It's possible we're going to end up finding that. Oh, you know what? We could do storage. Let's try this. I think if we did storage.erase file system, it might actually work. It can't restart, but it can. Does it have to do the restart? I forget how it works. I can't remember whether it erases before it restarts or after. Not seeing anything yet. Is it supposed to present a serial port via USB? If it's your first time running it, maybe wait a little while. But ideally, thank you for trying it. When I first formatted it, it did take a little while to like create the file system. So that's possible. What I recommend doing is if you have a USB to serial device or even just another CircuitPython device you can use for it, is to look at this serial output on the pins at the top, which is what I'm having my USB to serial converter do. That should be able to tell you how far it's getting, if at all. Let's see what this gives me. Never said it would work. I just said you could try it. That's the way it goes around here. Let's see what this does. Yeah, so it still has my own code, which is a bummer. Storage.erase file system. Oh. Well, it didn't restart. But I can restart it manually. Wonder how big it is now. Or let's just see. See what happens. See if our drive size is right. So it popped up again. It's just so slow. Ugh. Properties. Heyo. At least, okay, so it formatted it the right size again. Looking for the soldering iron. Yeah, Dan had to do this earlier too. I had Dan test, and he's like, I gotta put headers on it. I have various ways to have pi pins on a clue, or a feather, or a pico. So having a unique pi pin name would make the same code work on all the pi hats and bonnets, whatever way I do it. I've been starting to just call it GPIO number, just like the pinouts diagrams do. But I'll add ones for like SDA and SCL and stuff. And in fact, Linux has names for the pins too, so I was thinking of those as well. Is there HDMI output? I think I just turned it off, unfortunately. I could turn it back on and give you a build. Here, I'll do a build with the display on and see. I don't know why it's... Oh, you know... No, I do have... I did update the MMU stuff. Hammer headers to the rescue. I'll do a display build here. It's still pretty slow, and I'm not sure why. But at this point, I can't let myself get distracted. I've just got to, like, try it. So let's turn this back on. Do another build. And we'll try it on... I'll try it myself, and then I'll post this build as well. Thank you for help test with this. Helping test with this. Ugh. Overwrite. Sync. Works on a 4. The build I sent you works on a 4? Oh, it's a question. M. Lindholm says, did you say this would also work on a Fat Pi, a 2B, 2B plus, 3, or 4? I have a 0 tube, doesn't mean I need to use one. So yeah, it should work, not this build, but another build would work on the 4 as well. There's no B after it, is there? I think it's 4B. It works on there, and it works on the compute module 4 as well. But not the build I posted. The builds I'm making are board specific, basically. If they have the same chip, they should work across them, but they have like the name of the board that it's built for built in. It's not dynamically detected. Okay, so this is the one with the display, and I'll just test that it's working without. Oh, you know, I have it set up. Let's see if this works. Let's push my USB further. Like it. Is it outputting anything? HDMI. No, it's not. Ryan says, just tested and USB boot does work great for CircuitPython with the loop option that keeps it running so you can reload with just a power cycle. How do you set that up? Could you send me a link? You like how the cat's hanging out behind me here? All right, 3:30 is my deadline. I've got to show some other stuff. Pi 400 is not going to be that interesting until we get USB host working. There we go. So if you haven't seen this before, HDMI output does work. And I don't know why we're getting that, like, getting straight into the serial. But let's try with USB. Pogo pin clamp. I wonder if I should buy more. I'm like, should I hoard? No, it's not working now. Could be. Yeah, see, so USB is not happy. This is my life. This is what my, like, week has been. Of just like, oh, it doesn't work. Something's happening. Let me go in here and pull it up in the... Oh, you can't see. Sorry. You don't need to see the frozen screen. Or my hand. I just can't help myself. I've got to see what the backtrace is. And it's exactly that again. What was it? Current interrupt? 72. So we're not actually in the interrupt. Like somehow we ended up there. I really wish there was a way to like that. Embedded programming is a non-stop battle to convince yourself you're not insane when things aren't working right. I feel ya. I really do. So current interrupt 72 is the maximum number. So that means that we never got into the interrupt handler. We're just in this weird state. Where like something happened. This is like what? I don't know. I'm gonna have to stop. This is what my week has been. Let me tell you. Like it's telling us we're in IRQ, which is in boot S. There's a jump to IRQ. So this is why it thinks we're in IRQ. IRQ goes into IRQ entry, branch and link, IRQ exit. It works. What did you get working, Bruce? Running around to find all my stuff. SD card image, Pi powered, HDMI found. Where's my HDMI capture card? So I didn't share the HDMI build, did I? It's not working as well as the other one for some reason. Right? HDMI on. Go to W. Just the REPL, yeah. Yeah, the REPL's been pretty solid. And you can like do the OS stuff from there. What happens if I disassemble? Like, what instruction am I on? Huh. I'm on ERET. Did I somehow get into this code not in an interrupt? The current interrupt thing is all within handle IRQ. But if we're not actually... Yeah, if USB is not working, you can get the REPL on the UART pins. I might disable that in the long run, but until USB is reliable, I'll leave that on, obviously. Okay. What happens if you call ERET when you're not in? Like, how do we get there? Thanks for the DigiKey hint. Ordered my Pi 02 with a bunch of other stuff to get free shipping. Nice. I was so worried. I saw, oh, there's only 2 left. I didn't order anything else, and now I'm really kicking myself. 1, I should have realized I could buy 2. Maybe I will. Maybe I'll take a look. I think there's a STM board that I probably can't help myself and pick up. The Nucleos are just so small. Or it's so cheap. Ah. RPI boot CircuitPython directory will boot the REPL without even needing an SD card. Alvaro says, I'm probably going to have to rewatch the series CircuitPython plus Pi 4 bare metal. I just came out of a LF course and I'm a bit less clueless about embedded stuff. Would be nice to redo this work, but with a Beagle 5. Yeah. Yeah. For a new CPU architecture like that, you'll have to figure out all the compiler stuff and then the boot initialization, and then any MMU and interrupt stuff. If you're clueless about embedded stuff, start with a microcontroller. The application level processors are much more complicated. I wouldn't jump straight to the application level stuff. So I don't know, like if I just continue, break again, like I'm just on the same instruction. Like, yeah, LS Linux Foundation. That was my guess. Huh. So it is interesting that, what do you think all these 5s are? 5 is 0, 1. King of North says, thanks Scott, I also just bought 2 of the Pi Zeros and a few other things that I needed to go to Canada. There is still no RISC-V microcontroller with a USB. True, but you could do the C3. I guess CircuitPython already runs on the C3, but I thought there was. Isn't there like a GigaDevice RISC-V controller with USB? Could be wrong. The chip on the Beagle. I thought the Beagle 5 was canceled. I think you got an early one though. My Belgian dealer has Pi Zero W2 with soldered headers. Should I be lazy? If you want to support them, I'm sure there's a lot better margins on the headers. Dexter says, seeing Blinka on HDMI looks like I still need the serial though. Yeah, this is why I'm like so close yet not there. It's just like, it's almost working. It's just like some sort of bug. Some sort of bug that's causing me problems. Like, maybe it's a... Yeah, I don't know. Again, like, this is where I really want, like, a backtrace that starts from the top. So that when the bottom clearly is broken, I can still see the rest of it. And maybe I could just, maybe I should just dump it. Native USB, yeah. Not simply an integrated USB to serial. Yeah, but I'm saying like if you want, yeah. If you want to play around with embedded RISC-V, you could do that. You could do it on the S3 or on the S2, but with the low power core. The low power core could be RISC-V. It's not very fast though. I mean, maybe this is where I need like a trace. I don't know if I can do traces. It probably makes more sense to just do print debugging. Unfortunately. Let's switch gears. I've spent all week on this sort of stuff. If it sounds like folks have it building, so if you want to fix it for me, that would be awesome. I might have a few changes in my code, so I'll push those after the stream as a backup. Like my computer's been so unreliable, it's like gotta get it out there. But we've got 30 minutes left, and I want to switch gears because we have some other exciting stuff that's finally getting there. So let me take the second time code of the day, which I'll probably scrub through add a few more. Okay, so the other update that I want to cover today is actually the state of the PyLeap workflow stuff. So let me just clear my desk a little bit here. By clear, I mean just like unplug this Pi Zero. So as we've talked about, we've said there are going to be 2 apps, and so I want to show those off. Because they're both available through TestFlight currently, which means that I'll drop links in the Discord chat. And you asked for a reminder. Yep, perfect. 30 because you want another topic to present. Yeah, so let's talk PyLeap workflow and PyLeap apps. Let me find the links, and I will post them again in the live broadcast chat. Bye, Pierre. Blowing snow. Yeah, get home. Okay, so here is the link for Glider. So you can now, Apple has a program called TestFlight that allows you to test apps before they're in the App Store officially. So these ones have gone through a minimal review process from Apple to allow us to send like public links like this. And then it will auto update the apps and stuff. So this first one that I just linked, File Glider, is a generic iOS app for transferring files over PyLeap to and from a device. It uses the openly available protocol that we created for CircuitPython, but it is not CircuitPython specific. So you should be able, if you do PyLeap work and you want to be able to transfer files, the File Glider app will work with whatever, not just CircuitPython. In practice, it's actually pretty nice for CircuitPython right now as well, although it doesn't cover the serial link. So there's the first one. And I will show that in just a second. And then here is the other app that we have. It's called PyLeap. And PyLeap is an app to get you jump started with CircuitPython specifically. So it's taking kind of like a curated list of learn guides and making it really easy to just get those on a device. So move more stuff here and get out my phone. And let me now realize that it's rotated. You can see this is my HDMI for my screen here. So what I have here is I've got, let me snip this off. So I've got my glasses that I did my Halloween costume on. I'm going to finally take these off the glasses so I can set them on the table. And do I care about this rubber band? No. It's more expedient for me to just cut the rubber band. Okay, so what we've got here is we've got the LED glasses. I've got a Circuit Playground Bluefruit, and it will actually work with other boards. But this is what I got so far. So here's what it's currently doing. Can I fit it all on the display here? Let me clear out my notifications. And then, so here's my phone. And TestFlight, this is what TestFlight looks like. Obviously, I'm trying KDE Connect as well. But here, this is kind of how you can curate what things you have installed via TestFlight. So if I just go to File Glider, I've actually already connected to the Circuit Playground, so it remembered that I was connected, and I can just do explore, and we can take a look at, like, this is the code that's running on the glasses right now. So I could modify that, and in fact, maybe I can do that. Let's just do time. Oh, it capitalized it. Import time. And then I don't know how many indents to do. Time dot sleep 0.1. Done. Hit save. Is that slower? I think that's slower. So you could see that, like, File Glider here had to, like, wait for the reconnect to happen and send that over. So this is the prosumer low level work with anything thing. And I should also say what you can do is, I think this probably says shrug still. So we don't actually have instructions. But because I'm connected through File Glider, I can go into the Files app. So if I pull up the Files app, now I see the name of the device here. So actually, it's already there. So this is the top level, and you can click File Glider and see the devices that you're connected to. So if you're connected to more than one device, you should have multiple folders. And you can click there, and now I can see all the files again. So this allows other apps to edit the code over BLE instead. So if I hit code.py now, it opens the code.py in Pythonista. What app is this? I don't even know. It's either that or like Coder, I think is what it's called. But if you can see it blinking as the app like auto saves. So if I just write it there, and then it saves in the background, which makes it kind of like hard to tell when it's doing stuff. Like, I don't even know, did it go? Like, we could make it real slow. And again, all of this is like not CircuitPython specific. So that's pretty quick. I expect a sleep of 2 seconds to be really slow. Maybe if I back out. No? I can't tell. Maybe that's slow. So one thing you can do, I think, is in File Glider, which is here, if I go back there, there's actually a log here. So you can see which way is new. We should change this so it's reverse time. But we can see, like, this is like for the nerds out there. But you can see that it like wrote files, and like there was concurrent list directories happening. So this is meant to be low level. It's meant to be very much for debugging. So that's one of the options. That's File Glider. And then let's show the other end of the spectrum here. So PyLeap, on the other hand, is meant to be kind of like jumpstart, get you going. So what we have here, the LED glasses, is this bottom one. But if we do blink, I've already downloaded it. So there's an extra step where the send bundle button would be for downloading it. But if I just hit send bundle, now we can see that these lights stopped because it stopped communicating with the glasses, and now we're blinking on the blue fruit. So now if I go back and do the rainbows and send it, now the blue fruit's doing rainbows. So this is the opposite end of kind of what we're going for. This is the, I just got a blue a Bluetooth device. I don't know how to use it. So I just want to like find this Adafruit Learn guide and just start with that and get that going. So that's really what PyLeap is all about. That's why kind of like it's the leap that you're making in my mind. And we're actively working on getting more things in this list. It's all super early, so if you find bugs, please let us know. But the TestFlights are a way to test that. So that is the first two, and I just realized that I may not be able to reach the third thing I wanted to show. So let me just, oh wait, here it is. So if anybody's an Android user, you may feel pretty left out because those are two iOS apps. However, we have an alternative for you, and security update available. So here's my Android, and this is Chrome. So this is not a separate app. This is just Chrome, but it's code.circuitpython.org. So this is live right now, and it tells you to enable these two experimental flags that allow Chrome on Android to do experimental stuff. Now, Melissa's been working on this, and she just told me earlier today or yesterday that it actually does work on Mac, Linux, and Windows as well. So if you're on Chrome, you can do this web Bluetooth stuff from the desktop as well. So this is just the only option for Android, but it should work on other stuff as well. So make sure you set these flags that'll enable the new Bluetooth APIs. And then these aren't connected right now. I think they can only be connected to one thing at a time. So if you want to switch, like this device can only be connected to one thing at a time. So the way to reset that, and let's just unplug these for now. The way to switch so there's a process called bonding, which is like what device this device is like expecting to connect to, and it remembers. Johnny says, are we done with CircuitPython on the Raspberry Pi yet? We're very, very close. Watch the earlier stuff. There's just a few crashes. Everything kind of works. It just doesn't work reliably, unfortunately. Okay, so to switch, you're going to press the reset button. So this is how CircuitPython likes to do things. So we're going to press reset. It's going to flash yellow for safe mode and then blue for Bluetooth. And so we're going to do this, and then when it's blue, we're going to blink it, and it restarts again, but this time it's solid blue to tell us that it's basically like discoverable is the term. So we're going to hit request Bluetooth device, and it's not working. So we'll refresh. There we go. But nothing. Chrome needs permissions to scan for nearby devices. Oh, you know what? I updated my... Oh, look. I updated my Android version. That's why it's got a new permission. So now I see CircuitPy, which is the device, and I'll pair with that. And it has this nice thing, and I'll say pair and connect. And I won't give it access to my contacts. I actually haven't tested this beforehand. Johnny, I was sending test builds out earlier. Are you going to put some of the existing Bluefruit bundles in there, like stuff from AdaBox 14? I'm not sure. If you have suggestions, please let us know. I did not test this beforehand, so this is... And this is new Android. All right, so let's just give it another... I'm going to refresh that, and then I'm going to do... I don't have any secure stuff in here. So connected devices, let's just forget the So this is the like bonding side of, okay, so we're cleared out. This is the bonding side of Android. So let's reset here. And we refresh the page. Let's try it again. All right, so we didn't have to give those permissions again. Pairing connect, no contacts. I don't know why it's blinking red. David says it did more or less the same thing to me less than 24 hours ago from Chrome on Windows 10. It didn't get past this stage. It's possible there's some bugs still. Nothing. So I know how we could debug this, but we're just about out of time, so I don't think I want to do that. Phil asked me to try to do a like quick 1 minute video. So I think I might just try to do a quick 1 minute video on the iOS apps. Now, one thing I should say is we just released, Dan released 7.1 beta 0. And if you're trying this Android thing, you're going to want to do that because it's got a fix for using Android with it. So yeah, this is not, Melissa's demo earlier this week worked, but I'll have to chat with her about that. Never got to step 3. Yeah, that's interesting. Yeah, this is the problem with Bluetooth. So that's kind of finicky. So if you are trying this, there's a way to debug, and I think I showed this a number of weeks ago when I was actually working on it. You can actually get the serial or the console JavaScript console output on Chrome on your desktop, and it mirrors the rendering as well. So that's how you would go about debugging this, is you would see like the console output there. But unfortunately, it doesn't look like it's happy with me. So let's give up on that. And let's see how I can explain PyLeap and it's good though. The other thing I should say is that I'm hoping to make a page on CircuitPython.org. I thought I would get to that today, but it's not looking like it. I'm going to put a page on CircuitPython.org where the TestFlight links are, and then links out to like how to install the different apps and things for this. So check that out. Hopefully next week. I just have been sucked into this Raspberry Pi stuff, as you could tell. Okay, so let me see if I can't do... Oh man, I just went straight to Twitter. That's what I've been trained to do. Let me... So before I do this like 1 minute thing, I'm just going into my Bluetooth devices and making sure that I forget this, because Apple in particular is pretty picky when the like keys change. So... PyLeap. Yeah, so PyLeap discovered that it's no longer connected. So let me just clear these out. Hello everyone, this is Scott from Adafruit, and I just wanted to do a quick video on how to connect to a CircuitPython Bluetooth device from an iOS app. We've got 2 app options here for you. So the first thing you're going to want to do is press the reset button and then press it again when it's blinking blue. and then it will be solid blue. That means that it's discoverable. And then you can go into either app, but preferably PyLeap to start, and it will find the new device, and now we're connected. Currently, PyLeap has 3 options for different sets of code that you can start with. We're already doing rainbows, so we'll do blink. You'll click here to download and then click a second time to send it, but it's been cached for me. So it's super quick to switch between projects. And then we can switch back to rainbows. Or we can even do the glasses that are connected externally here. So if we do that, hopefully, yeah, it's got a lot more files to it, so it takes a little bit longer, but now we've got that third project. It's meant to get you started with CircuitPython really, really quickly, so that's PyLeap. Check circuitpython.org for more information, or adafruit.com for more information. The second app that we've got for you is Glider, File Glider. File Glider is a much more low-level file transfer, so you can browse the files on the any device that does the file transfer protocol CircuitPython is doing. So we can see here like what our boot out text is, for example. We can see a debug log if we want to figure out what happened when things don't go right. And last up, we can also use the Files app to browse all these files. So if I do a quick off-screen, pull up the Files app, from the top level, what you'll see now is a File Glider item, and then you'll get folders. Oh, oh, I crashed it. I was on a roll. I don't know why it's not working. Well, I found a bug. But normally what you would do is you would be able to click in here and get a folder for the device and then browse the files there. We can actually go back to Glider here and just see if there's any logs at the bottom here about what went wrong. Ugh. We need to make it so that we can see here there's an error here that says invalid internal status, invalidating all received data. So that's super helpful. Maybe what we'll do is I'll kill Glider, I'll kill files, then let's go back and do, oh, that's not right. So let's just pull it up again. We're connected. I've realized I'm over time. There we go. So here's File Glider. We can do a time warp. Now we can click here, and it will load. See if it works. It might still be unhappy. I'll have to send this video to Antonio. WebVSK says, ugh, stay off Twitter. I feel ya. And so close. You sounded really good up until that crash. Thank you. These are early. I don't mind showing crashes on the live stream. We know that there's always crashes and that we can fix them. But I'm not sure what the issue here is. Something's not happy. I can't even I can't hit back to go there either. Bummer. The Explorer still seems to work. I think that the file, there's a thing called the file provider and it runs separately. There's an untitled folder that looks wrong. So yeah, give these a shot. Let us know what you think. Obviously, it's early. I know it was way too long. I wanted to think I was on time. I'll go back and add time codes to this. I can add time codes after the fact. Use the part when you were showing us earlier and add the voiceover. That's true. I could do that. See, the problem is I don't really I don't have the skills to edit video, so that's part of the problem. Alvaro just said take two. I'm not sure how to get it working again, actually. Any questions about that? We're just about to wrap up. We'll get it fixed. It's not a big deal. Mm-hmm. Sad trombone. Let us know what you think. You could do it in CircuitPython dev, or the source code is open as well for both of those. So and TestFlight has a way to give feedback as well. So all of those kind of should work in terms of giving us feedback about how it works. But we're so close, just like this other stuff on the Raspberry Pi, like so close. Reboot the phone, reset the Bluefruit. Yeah. Hopefully it wasn't a CircuitPython side issue. Although Melissa did find one issue when she was doing the Android stuff. But yeah, let us know what you think. If you are an app developer, want to give a shot making better apps for it. Oh yeah, David said, so now we need Black and Pylint on the phone. I love this idea of having like a more structured code editor. But it's a lot of work, and we've been doing a lot of this basic mobile work already that I think we want to wait and give it a little bit of time. Thanks, Minnesota Menta. Have a great weekend. I'll try to, I don't know what I feel like doing. I feel like I need to check in with people. But if you sign up for the TestFlight, you'll just get auto updated, which is cool. The code.circuitpython.org should work externally. Cheese says, I think on Android you could attach the CircuitPython device as a USB storage device and then use Emacs and Termux. Yeah, perhaps. I would actually like to see USB support in code.circuitpython.org as well. I think that would be neat. Any last questions? I'd love to figure out why the Raspberry Pi stuff's not stable. Like, if we're doing an ERET, what happens if you ERET when you're not in an exception? It should probably tell me. I'm not connected anymore. That's the thing that my brain's just going to be like. I'll send that link to the app folks and be like, oh, Foamy Guy says most Android devices I've seen don't support the type of FAT formatting of CircuitPy drive on devices. FAT12 probably. By the way, the Pi worked for me in the end. HDMI storage and USB serial. Thanks and bye. Wow, it all worked? Was that with your own build or? Android can communicate via serial through a to and from REPL. You can edit files if your storage is writable. It's pretty wild that the Pi worked. I don't know why it's crashing for me like that. It's a very weird crash. I wonder. I could probably fix my. That's what I should do. I could probably fix my stack on Wonder. Yeah, Melissa did some work with WebUSB to update the ESP devices. So she would definitely have the skill to add it to code.circuitpython.org too. Like code.circuitpython.org looks really nice now. All right, well, that's it on time. I'll ask any other questions that come up. Otherwise, I reiterate things. So thank you all for hanging out with me here on the stream. Next week will be 2 p.m. Pacific on Friday, and the week after that will be a week off. Again, that's a deep dive. It'll be just like these 2 hours here. If you want to chat with me and a lot of others outside of the deep dive, you're welcome to join our Discord server by going to the URL adafru.it/discord. That's the middle box here. The bottom one is YouTube, and that goes away at the end. And thank you to Patrick and David for doing time codes. David's not actually here today, but I'll do my best to give some rough time codes. And Patrick puts them together on the deep dive repo, which is awesome. A great way to search for it. I'm sponsored by Adafruit. So if you want to support me, please support them by going to adafruit.com, purchasing some hardware there. And obviously they pay me to do all this work, so it's been awesome. That's it. Thank you all so much for hanging out with me today and testing and trying all these new exciting things. Are kind of all getting to this point of being like so close. So thanks all for hanging out. I'll pet the kitty. He's on the chair behind me, and we'll have a great weekend. So thank you all. I don't have to switch to cat cam because he's just hiding behind me. You like the chair, kitty? Not quite as cute, huh? Surprised you're not in the window. Have a great weekend, everyone.